Have you ever seen one of these before? These are the FPV goggles of the late 1800s. This is a home-style stereoscope from 1895. Yeah, this thing really is 130 years old. They're not super rare. You can find them in antique stores or on eBay for around $50, but what they do is really cool. A stereoscope viewer uses these cool old cards, which you can also find for cheap at almost any antique store, which have two photos of the same thing taken from a slightly different perspective. The stereoscope then isolates one photo to each eye, and your brain interprets the difference in perspective just like you were seeing the thing in real life, and it shows you the result in 3D. So wait, we've been doing 3D photography for 130 years? Yeah, actually it's a lot longer than that. It's closer to 200 years, which is pretty wild to think about, isn't it? Now, you've maybe come across something like this stereoscope in the form of a toy, like this Viewmaster. It's the same principle though. Two photos of the same thing, if I can get the reel out, from different perspectives that you show to each eye separately, and your brain makes a 3D image of it. Now, we talk a lot about how to use photogrammetry software to make maps with drone imagery, but did you know that the same photos you're taking to make maps, digital maps and 3D models, we can use in these old school analog stereophoto viewers like this stereoscope or one of these inexpensive 3D card style viewers, or even this Viewmaster toy. Now, this is one of my favorite things to do with drone photos, because if you get a good set of photos of something that's really interesting, the objects just jump right out of the photos in the viewer. I take sets of these photos that I've printed out whenever I go and guest lecture about drones and drone mapping, or I visit like K through 12 classrooms. This exercise is a ton of fun, and it helps people understand a bit of the theory that our fancy software is using when it's making your maps. So what do you need to make stereophoto pairs from your drone images? Well, really, you just need two things. First, you need images with a high amount of overlap between them. You can do stereo pairs with any two photos that overlap by more than about 70%. But the less overlap you have, the harder your brain has to work at assembling the 3D image. Also, you can only get the 3D view from the overlapping portions of the photos, so at lower overlap amounts, you're going to have less common area between the two photos to work with. I found the best results come from using photos that have somewhere between 85 and 90% overlap. Good news though, when we're collecting drone photos to make maps, we're almost always shooting with a high enough amount of overlap for us to do stereo pairs with them. The second thing that you need in order to do this is for the location shift between the photos to be only in one direction, typically along a straight flight line. This is because your eyes are set horizontally in your head, and your brain is tuned to dealing with changes in relief displacement only in this horizontal dimension. Okay, again, it's usually not a problem if we're shooting photos to make maps. We just select the adjacent photos in a flight line, and then we rotate them so that the change in perspective is along this horizontal or x-axis. Okay. If you're free flying though, or shooting video, you need to make sure that you're getting sort of adjacent photos that are along a straight segment of the flight line. So let me show you how I make the stereo pairs. I'm sure there's tons of other ways of doing this, but this process works reliably for me. The first thing is to find a set of adjacent photos along a flight line that have a high degree of overlap. I use GIMP for adjusting the photos, but you can use any photo editing app. Once you've brought your photos in, you'll need to rotate them because the change in perspective as the photos were shot from the drone is along the y-axis of the photos for landscape-oriented drone photos. But for our brains to make sense of it, we need to change that so the perspective is along the x-axis, and we do that just by rotating the photos. Now with that done, we can clip an overlapping portion from each photo. If you have a lot of overlap, say 90%, you can actually just use the full original photos. Your brain won't be able to make a 3D image for the portions of the photos that don't overlap, but as long as that's just at the edges of the photo, it's not too distracting. I usually clip out a smaller portion of the overlapping area from each photo, trying to match up the area in each photo as best I can, and then I export the clipped photos as JPEGs and label them left and right. Okay, so we've got some cool photos with good overlap. How do we view them in 3D? All of the 3D viewing techniques involve looking at one image with your left eye and the other image with your right eye and allowing your brain to merge the two different images together. And this mimics how your eyes would naturally see the world around you. Two different images of the same thing from a slightly different perspective. If you've got the photos switched around backwards, the 3D will be reversed and the objects will actually go down into the image. This can look pretty trippy depending on the photos you have, but if you don't see them pop in 3D, just swap them around and then that should take care of the issue. The first approach to viewing stereophoto pairs is called free viewing. And this is the simplest way to view your drone photos in 3D because you don't need any equipment to do it, but it can take some practice to get good at the technique. I find the technique that works best for me is called cross viewing or cross-eyed viewing. Basically, you're going to switch the photos so that the right one is on the left and the left one is on the right. And then step back a little bit, cross your eyes and look at the photos. And as you do this, you'll start to see three photos. And you'll want to just concentrate on the photo in the middle. Now, don't try to focus on it so much as just pay attention to it and try to relax your eyes. And as your eyes settle in and adjust their focus, the middle image will pop into 3D. And at this point, you can kind of scan around the image and sort of take it all in. So I'm going to put one up on the screen now. Go ahead and pause the video here and try it with this set of photos. Now, the second option is called image wiggling. And this is kind of a funky technique, but you lay the overlapping portions of the two photos right over top of each other, and you toggle back and forth rapidly between them. And this tricks your brain into simulating the 3D nature of the photos. This works really good as a looping animated GIF file that shows each photo for about a quarter to a half a second. For me though, this only seems to work if the photos have like more than 85% overlap. Still, it's kind of cool technique. You can make GIFs and put them on a website for people to look at. The third option is to use a stereoscope. And for this option, obviously you'll need a stereoscope or some sort of stereo viewer. You print the photos in parallel on a card that fits into the stereoscope, then adjust the slider until it's in focus. Let your eyes relax and enjoy the 3D view. These card type stereo viewers are pretty cheap and available online. They're a little bit harder to use with the cards, but with some practice, they work really well. I made up these old-fashioned looking cards to highlight some of the cool photos we've gotten on missions from the drone lab last year. These would make great gifts to share with family or friends or clients, some promotional material or something to take to a classroom and get kids excited about drones and STEM education. That's it. This is a super easy but super cool technique. I love it because it really engages people with drone photography and mapping and is a great discussion starter. I'll post some of our photo pairs from this past year on the Drone Labs website and put a link in the video description. I'd also really love to see some drone stereo photo pairs that you come up with if you decide to try this out. Thanks for letting me drone on, and I'll see you next time.